The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody, and thank you so much for coming to the rebroadcast of this webinar. I'm really sorry about the technical problems we had last week, but thanks for coming back again this week. We've got a great presentation today. As you know, Jeff Garbus is an expert on Sybase and SQL Server, SQL and ASE, as it's called now. And we're going to be discussing today how databases and slow applications affect the performance of your applications. And we're going to specifically go through some case studies from the healthcare industry, and so how the health of your database affects the healthcare industry and clients and patients of all kinds. So without any further ado, our CEO, Jeff Garbus, author of 20 books on Sybase and SQL Server and database management, is going to take it away from here. Thank you very much, Jeff.
Thank you very much, Devin, and thank you all for attending and sharing this next hour or so with us. We did have a few sound problems last time. I have the questions section open here on the presentation, so hopefully if there are any problems, somebody will let me know immediately. I'm going to skip the About Soaring Eagle part. I'm going to do this toward the end. The short version is we are a managed services and database consulting company, all expert, all onshore. So let's talk about open enrollment. Let's talk about heavy hitting times. Let's talk about what happens if things do not work out as planned. So most industries, I'll rephrase that, many industries have these points in time where bad things happen to systems that are not adequately tuned. So for example, if you're in the credit card industry, we know that on Black Friday, the day after Thanksgiving, everybody is going to be shopping, and the number of credit card transactions to be processed are going to be dramatically higher than they are in, say, mid-June, because that's when the Christmas shopping starts, and that's where vendors decide it is time to push people into their stores and try to get the beginning of the Christmas shopping done and put lots of sales in place. In the health industry, there are other times that tend to peak, usually around the time that plans are changing. So we talk here about open enrollment as one of those times and one of those possibilities. And when plans change, when people change benefits, when the benefits roll, we have one client in particular that pays us to sit and watch from 1 minute after midnight on New Year's Eve over the course of the next week or so. We are 24/7 literally just watching their performance monitors. The reason for that is historically that's when things are going to crash, because that's when they have their highest volume of everything from queries to what is my plan doing, to let's make the changes, to let's place an order, to is my doctor still in the plan? And the types of queries are very, very broad. So we did perform a major tuning exercise there, and we got to the point where the following year they didn't ask us to. The following year they did ask us to do it. Absolutely nothing happened, and they were floored. And so the following year they didn't bother with that particular approach. They're a managed services customer, but as a group that cares about specific days, specific overlaps, that threshold for high availability becomes very important. So as we look at what happens when the crash happens, obviously our first suggestion is going to be don't let it happen in the first place. So make sure you have your incremental backups. Make sure that your backups are restorable. If you can't restore from your backup, that in of itself is a problem. One of the questions I get asked frequently is, how often should I back up? And one of my answers is, how long does it take you to do a restore? Because if it takes you 5 hours to do a restore and your downtime window is a few minutes, clearly whatever backup process you have isn't working, and it really doesn't matter how often you do it because it's not going to work. In general, you want to make sure that whatever backup processes you have come within your operating SLA, and that's a business decision. That's not a technical decision. I'm also frequently asked, how often should I take my incremental backups? And my question is, how much data can you afford to lose? Because halfway in between your incremental backups is your mean time to failure for your losses. So as we start looking at this, make sure you have the backups. Make sure you have tested the restore. Just because you have the backup doesn't mean it works. I have had customers in the health insurance industry that have had failures of their restore systems relatively soon after spending $500,000 on them. Make sure that your backup, and I'm a database geek, so frequently I tend to be very data-centric, and I want the data to be backed up. I just don't always think about the code because I always assume that it's very easy to put that back together, but from a failover standpoint, it is equally important to make sure that whatever you have failing over for your databases also fails over for your middle tier and your front end, whether it be Fat Client or IIS or Apache, whatever those happen to be, because otherwise you have that downtime window that you're contending with. So make sure you back that up. Make sure that everything is documented. One of the things that a lot of shops do not do often enough is build and test the run books by having the operational staff make sure they can restore bare metal when that type of thing is absolutely necessary. So that run book becomes your disaster recovery document as well as the run book that you're operating out of. The next issue is make sure that you prepare for growth. I have seen lots of companies that were the victim of their own success. One of the things I get called in for with some degree of frequency is not only, well, we went from 100 customers to 800 customers, but we went from 1,000 customers to buying our 3 largest competitors, and now we have 5 times the volume that we did before. So looking at scalability issues is another important step to making sure that you're not going to have any downtime. This also becomes critical as you start hitting your enrollment day or whatever your high percentage heavy hit time is. Note that capacity planning is not a budgetary thing, not just a budgetary issue, it's also a nuisance control issue because you don't want to, for example, run out of storage because you are losing, because you're unable to move forward and or lose customers on that bad day. Few things to include in that DR plan to help assure that it doesn't happen in the first place. Make sure that you have people ready to go and monitoring when that heavy hitting day occurs. Now, monitoring does not just mean sitting at his or her desk. You're going to want some sort of tool. We'll talk about tools later. But you want some sort of predictive analysis. You want to see that the CPUs are going from 40% to 60% to 80% to 100%. You don't want to start looking at this when it hits 100% and the phone starts ringing. You want to be proactive about that. In order to be proactive, you do need to make sure that you have the availability of your senior level staff and that that senior level staff is not being worked crazily. I've had multiple customers that had a single DBA, and that single DBA was working 80 and 90-hour weeks, hadn't had vacation in literally 3 years. I will go back and say, you know, I'm not suggesting this is going to happen, but what if that person quit? You're going to need 3 people to replace him or her, and it's going to take a while for them to come up to speed. So make sure that DBA has a work-life balance. Make sure you have a bench behind that person, and that bench does not need to be a people. It can be a service. That's one of the things that we offer, and we'll talk about that later. Make sure that your maintenance, all of your preventive maintenance occurs. This is not just things like incremental backups. This is also things like index rebuilds, statistics updates, DBCCs if you're running Sybase or SQL Server. Oracle has an equivalent as well, but I'm not an Oracle DBA, so I can't tell you where it is. Make sure that your DR plan includes where the bodies are buried. And here we're not talking about literal bodies. We're talking about things like, all right, I have to restore from backup. Where is the backup located? If I choose not to restore from yesterday's backup, but to go back a week, is that online? Do I need to request it? If so, how do I request it? Can I get the correct one? Then all the incrementals in between. How does your DR work? The disaster recovery might be automated, and a lot of shops do test these on a periodic basis. They just simply roll over and they watch to see if their customers notice. This is a great thing to test way before your enrollment day. So what type of DR do you have? Is it a mirror? Is it always on? Is it automatic? Have you not tested it? Is it manual? Have you tested the manual failover? This is probably more important than testing the automatic failover, because if it's manual, that means there's a process that needs to be followed, and where there is human intervention, there is room for human error. Do you have the ability to do a bare metal restore? This is something that you should test on a periodic basis. How often? Well, some industries are regulated and they're forced to do this sort of test on a regular basis. Others choose to interpret regulations in such a way that require them to test this for all of their databases on a once-a-month basis. Can you do those restores? Can you rebuild from scratch? Make sure you have a test. Make sure you have a test system that's up to this. Make sure your DBA is reachable. Make sure that they know what to check and how to check it. Make sure that when you ask for a restore, you're asking for the right piece of information. When you're looking at a restore, we literally had a customer that wanted to restore their backup. They were unable to. It was a corrupt database, and they found that corruption had been in there for over 6 months. So the most recent solid backup was more than 6 months old, and they were unable to resolve the corruption. This is a very foul thing. For those of you who have tools that identify corruption, this is something you need to run prior to aging out a backup. This is just absolutely critical. There's not even a should we do it or how do we do it. It's you must do this, otherwise you're going to get yourself into trouble. Next, have you done your standard maintenance? Have you done performance and tuning? One of the things that we talk to our clients about and that we push for our managed services clients is to make sure that performance and tuning is a continuous process as opposed to a sporadic process when things go wrong. So as we look at new environments, now some environments don't change a lot. One of our clients is a hospital. Hospitals mostly have third-party software. They don't let you change those, and when they do, it is a major event. We go through a lot of testing. We make sure all the data works. That is a serious type of thing. Other clients of ours have a more agile environment, and things are literally changing every week or two. Now, on a good day, they'll let us do a code review. We walk through those things. We will watch what happens as the rollout hits. But we don't want to just look at the performance and tuning there when people complain. We want to pick those things up on a proactive basis. And that's our very strong recommendation. So short list, things to look for. And again, do this well before your open enrollment day. Run your DBCC checks. Make sure that you have a high fidelity database. We'll talk about that again in a little bit. Make sure that your indexes are there. Do you have all the needed index? Do you have have you gotten rid of your unused indexes? If you don't have a way of identifying unused indexes, that's a good thing to figure out. Do you have redundant indexes? If you have an index on ABC and another index on AB and another index on A, well, 2 of those 3 indexes can go away. Hint, ABC is the one to keep. Have you reorged your indexes lately? Have they been rebalanced and cleaned out? Check for the internal jobs. Have they failed lately? One of the things that we make sure we do is check for a success message or a failed message. But what happens if your agent goes down? You don't know if you've succeeded or failed. We'll also look for a missing or absence of a report of success or failure, because that's a different type of failure. Make sure your capacity analysis is reviewed prior to your big day. You don't want to find out a week before enrollment day that you're running low on disk storage and that you need to order some more. You don't want to find out that you're running low on memory, that you're running low on CPU, that your network is starting to move toward the edge of maximum throughput, because any of those things are going to cause a problem as you start to spike. So look at the graphs and charts you have that are coming out of your analysis tools and follow those as well as you can. Make sure that you have a bench. If something does go wrong, a human being can only function at maximum capacity for a finite period of time. None of us are perfect, and we are neither robots nor computers. So what happens if something causes a problem? Well, you'll work it through until you're at the point of exhaustion, and then you pass it on to somebody else. On a good day, you work it to the point of exhaustion, not through the point of exhaustion, before you turn it over. Or you may have multiple people that are working on a common problem on a common day. We did have a client that had 3 major disasters all on a Black Friday. It was not an open enrollment, it was a Black Friday. These were systems that we were not managing at the time, but we got called upon to help, and they were in 3 separate technologies. One was SQL Server, one was Oracle, and one was Sybase. We helped them work through each of these simultaneously through to resolution. Now, the problem you run into is you need staff and sufficient staff to be able to handle that. When it happens on a Friday, working through the weekend, you don't want people who have been working, 10, 15-hour days for the several days before, because it's going to take 2 to 5 times longer to get these systems up because people will be exhausted. They won't get it right the first time. I have had multiple clients that have had DBAs that simply do not get time off, that always get called on their vacation. Worst case, we had a client that we walked into. This was an insurance company that was relatively small, had a single SQL Server DBA who'd been working 78-hour weeks and literally hadn't taken a day off in 3 years. Now, I didn't at the time say this very politically correctly, but I did ask, what are you going to do if Bill gets hit by a bus? Because he's got everything in his head. There is no documentation. He does not have anybody as a backup. He's got all the passwords in his head. What happens if he gets hit by a bus? Now, I was extraordinarily embarrassed when a week later I found out that he was on his motorcycle and got T-boned by a car and was in the hospital. But the fact remained that he was working on a morphine drip in the hospital on his laptop because nobody else could do the things that he was doing. That first bullet here, DBA work-life balance, is important, but having a real bench, somebody to back up your staff, is also very important. If you have a 24/7 operation, and most people do, most shops do, even the ones that don't think they're 24/7 operations need to realize that they have maintenance that's going on over the course of the evenings in their low volume peak time, and people need to watch it. There's 168 hours in a week. A human being is usually going to work 40 or maybe slightly more at peak. That means you need more than 4 people once you figure in vacations and holidays and all the rest of it. Make sure that you have some way of giving your DBA team a break. Now, when I originally put together this presentation, it was targeted toward the CIO types, and I asked a few friends who were CIOs and CTOs, if I were talking at a conference, what are the types of things that you would want to hear an expert talk about? And one of them, who is a smart aleck as I am, said, well, define expert. So I went out to the internet, which is always correct. You remember the commercial. Said an expert is somebody who has already made all possible mistakes in a narrowly defined field. That is Niels Bohr, a Nobel Prize-winning physicist. And I thought that was a brilliant way of describing it, because experts aren't people who've taken lots of classes and gotten certifications and scored their PhDs. Experts are the people who've tried things, gotten burned, and have learned from their mistakes and built upon them so that they can do things correctly the first time, every time. I have added an additional category that I call guru, and these are the people that I like to hire. Gurus are experts who are able to talk in plain English, whether it be to a programmer, a DBA, or an executive. They can take that expert knowledge, turn it into action, create courseware, communicate well, mentor all the actors that you've got in there. So, expert sometimes is a little bit on the sit in the corner and get things done. One of the best definitions I've heard in the past for a brilliant DBA or a brilliant system administrator is somebody you don't know is there because nothing ever goes wrong. In the consulting field where I am, that is sometimes a problem, because if nothing ever goes wrong, people ask, what do we need you for? So what we found is that the people who can communicate as well are even more valued than the experts who make sure nothing goes wrong. So on the list of things that we were asked for is, what is my DBA actually doing? Well, you actually have two types of DBAs. You've got production DBAs and development DBAs. Here we're talking about a production DBA. The idea or the role behind the production DBA is to make sure that everything that happens on your system happens smoothly and efficiently. In order for that to happen, that includes making sure that the data is accessible, that it's accessible quickly, or rather within the terms that you have defined as your SLA, that only the people who should have access do. And note that that is not defined by the DBA, but that is often implemented by the DBA, or at least the implementation that's set up by your security people or enforced by the DBA at the data level. So the DBA is also watching for things like data blockages. We're also looking for whether maintenance is being performed. We'll talk about maintenance a little earlier. So that's the DBA as the soldier standing at the gate and trying to keep all the barbarians from flooding in. On the other hand, when it's time for the floodgates to open, that's your open enrollment day. It's the DBA that's going to make sure that of the million queries that come in the next minute, they all get responses within the next second. So that's the operational DBA. You'll also occasionally have a development DBA. The role of the development DBA is to do data modeling, to translate the logical data model into a physical data design, and to do the initial performance and tuning on the data model based on the types of queries that are coming in. So typically the performance and tuning starts with the development DBA and works through to the operational DBA. DR options are another thing that I was asked to discuss. So these days, there are only a few DBMSs that are really in use. Microsoft SQL Server, very high up that list. MySQL, very high up the list. Oracle, not as high up the list as it used to be. There are a few shops running other things, which include things like Sybase ASE, it's now ASC, SAP ASE, Hadoop, Mongo, a lot of third-party products. But really, as you start looking at the individual products, you're also looking at recovery and disaster recovery for these individual products, and how do we keep them up and running? Today, most of our clients that have the very high availability systems are looking specifically at SQL Server. So we do have a client locally here in the Florida area that is running, they're not a DoD customer, but they're running DoD standards because of the SLAs they have with their customers. What they do is they have a lot of processing. That lot of processing is mostly idle until something urgent happens. When that urgent things happen, they need to send 3 to 10 million transactions out within 3 to 5 seconds. So that's very sporadic, it's very aggressive, and the hardware needs are very high, and when it fluctuates, that's when things get important. That, by the way, is another reason to have those monitors on for performance, so that you can identify what's happening at peak, because otherwise you're going to miss it. What this particular client had to do, or what they asked us to architect, was a 3-state system along these lines. If a disaster hits 2 of the 3 states, and here we're talking United States as opposed to states of being or states of up, in 3 different states, what happens if one of the states goes down? At that point, the information is going to transfer to one of the other states, but what if 2 sites go down? And we were specifically asked to build a solution that allows full functionality, full performance, full data availability if 2 of the 3 physical sites go down. So one of the questions I get asked frequently is, what are you going to build for me? And my question is always, what are the requirements? And then as you talk to the business users, they really don't always know how to structure the requirements, so you have to help them build those requirements in. Not that difficult an activity if you're paying attention. So decide what types of disasters you're preparing for. Here in Florida, we get hurricanes. In Texas, you might worry about more floods. In California, Right now they're dealing with wildfires. They've got that earthquake in their back pocket too. So what is it that might go wrong? Look for other types of disasters, system failures, servers, storage. We had a client out in California. You would think that California's natural disasters would stop at mudslides and hurricanes and earthquakes and fires, but there's also the system failure that types of happen. We had a client invest $1 billion in infrastructure. They built a new building. It was earthquake proof and hurricane proof and flood proof and fire proof. What it wasn't proof of was the failure of their cooling system. And the fact that the alarm on the cooling system that was supposed to tell them that it had failed itself failed. They lost an entire data center overnight when their cooling system failed. Their data center went up to 160 degrees, and they literally had most of their systems melt. Unfortunately, this particular customer did not have more than 1/3 of the capacity to bring things up in other sites, and this was a very serious, very significant mad scramble. Take a look at your system failure points, make some plans. What are you looking for from a service standpoint? What would you do if your power was cut? What do you do if the internet is cut? I know multiple customers that have multiple internet providers. They come in multiple directions, so that if a backhoe picks up one of the sets of fiber, the other one hopefully is still running. They come from different directions from different providers. What if your power is cut? Lots of sites have backup generators. How long will your backup generator run for? Have you tested the power failure to the backup generator? Do you have sufficient fuel for your backup generator? How long do you have fuel for? Can you go 1 day, 3 days, 5 days? Is it as important if you have a failover site? And can you move directly to the failover site? Once again, this becomes a business planning decision more than it is a technological decision. Let the business people tell you, this is what I can deal with, and then you build it, give them a price, and they either blink or they don't blink. Build and test your DR plan. Testing your DR plan is, if you haven't tested your DR plan, you haven't got one. When you build your DR plan, find your local practical joker. There is always somebody with a twisted sense of humor who is a practical joker outside of the office. If you have a practical joker inside of the office, that is not a good person to have. If you have a practical joker outside of the office, bring them over and say, okay, where is the weak point here? If you were to maliciously go after my system, what would be the point that you would attack? If Murphy's Law were to be applied, where do you think it would hit first? And let that person help you, because if you've got a blind spot, that person is going to find it. I am the outside the box practical joker, so call me if you do have a problem or want an extra pair of eyes. Note that disaster recovery options are changing on a fairly regular basis. For example, we'll talk in a few minutes about Microsoft Always On. But early options included things like clustering. Clustering is a shared storage architecture and a shared resource architecture that allows failover in case of a primary box failing. Well, if we're not failing at the box level, what might be a problem? Newer options, which are software related, vMotion via VMware, Veeam, which is a block level database backup system, other DBMS-aware software products. Do some very cool things in terms of being able to allow you to go restore on a per object basis, which is difficult with the vendor DBMS approaches. Do you buy a tool? Do you use the new vendor features? Use a combination? Depends on your level of confidence in all of those. And regardless, I strongly recommend a significant proof of concept or proof of value, depending on whether you're a finance person or a technical person. I do like the always-on approach that Microsoft makes available. Gives you the ability to have multiple physical sites, to automatically push to multiple physical sites. If you like, automatically fail over to multiple physical sites. And the advantage here is, let's say you've got, let's take a simple US-based company that has sites all over the country. Well, what you find is that if you have a server in New York and users in California, you've always got this 50 or 60 millisecond lag in each direction for data to be transferred. And after a while, this adds up, particularly if you want it to be synchronous. So one of the things you can do is set up multiple physical failover sites, have your primary site wherever you want it for updates, but do your reporting, do your querying, do your web-based access based on whichever the DBMS feels is going to respond most quickly to where you are. Very cool technology. We have implemented and tuned and managed a 3-continent always-on failover, which was, honestly, it was a lot of fun. So data available to sites, multiple readers, fastest responder wins. This gets us away from the standalone technology. It gets us away from the replication technology. I do like to work with a single software vendor where possible. And the reason for that is when it fails, I've only got one vendor to talk to. Recently spoke with a CIO out of the Charlotte area, and he asked me, do you have a presence here in Charlotte? And my answer was yes. He said, that's good, because I will not talk to any vendor who is not close enough that I can put my hands around his throat. I really wasn't that happy with the way he put that or the way it was approached, but I understood his point, which is I want to be able to get somebody in front of me that I can talk to, and I don't want to have to go looking for the person, find the person, wait for the person to respond, etc. Performance is very important. So let's talk about what happens to your system when things are running really slowly. So let's take a call center. You're at a call center, you got thousands of customer service reps, and every single one of them is on the phone telling your customer, hang on a minute, our systems are running slow today. That annoys your customers, it annoys your customer service reps, and it also costs you a lot of money. If you just take 10 seconds times the 100 clicks per day, times 3,000 reps, multiply that by their hourly rate, it is amazing how much money a few extra seconds of performance costs you. But it also costs you in reputation because you've got your customer service rep saying, I'm sorry, our systems are running slow today. And when I hear them saying that every single time, they pick up on it. We have customers with who have in the past had slow-moving websites. That will lose you customers. I know that I have the patience of a 2-year-old. I think that's why I'm good at performance and tuning. And that means that if I'm on a website and it's not responding, I'm going to go to a website that is. Now, you do have to spend a few minutes defining performance. And that is one of the first questions I ask when I get called in, because people bring me in, they say our systems are running all slow, and I'll ask, well, what do you mean? And sometimes it'll be, well, we simply can't fit the batch window in our batch time. Sometimes it's end-to-end performance for our users are not working well. Sometimes it's monthly reports. Sometimes it's you name it. So we need to define where we want to get to by the time we get there. The other thing you need to do is start looking at this peak time issue, and that's what we're talking about from a performance perspective. We had a large insurance company, a recent customer of ours, that said, okay, our performance has been getting gradually worse over the course of the past few months, and we know that we're going to hit a peak where our volumes are going to be multiplied by 100 suddenly and overnight. Can you come in, quantify this, tune it, and get us to the point where we have a confidence level when we hit enrollment day? Well, we were able to. We actually, if you multiply this out, we made this about 150 times faster. But one of the benefits of making this about 150 times faster is that you can measure where the performance is and where the bottlenecks are at the new capacity. And you have to do it at the new capacity because at the old capacity, you may have been pushing your physical I/O, whereas with the new capacity, the physical I/O may just be screaming along, and your problem is a network bottleneck. So make sure you are testing with your current environment, not your old environment. So when it comes to performance, how do we start tracking this down? This particular scenario has been common for, at least the 30 years I've been working in IT. What ends up happening is people complain about performance. They say, okay, the database is running slowly. The database folks say, it's not me, it's the network. The network people say, everything's running fine in the network. I think it's the storage. The storage people say, everything is running fine, running at 2% of capacity with the storage. Talk to the developers. The developers say, everything's fine here, it's a database. And you go through this finger pointing session, and some people have rooms dedicated to these finger pointing sessions. They call them war rooms. And when the people call up with performance issues, they fill the war room, and they say, you're going to sit here until we get something figured out. Sometimes there's no hardware at it. Sometimes the hardware does not fix the issue. How do you know where the issue is? Really? You need to get a tool that quantifies this. So we talk about not accepting yesterday's performance. So I love this quote from Roadhouse. I think hardly anybody ever seen this movie, but it's a lot of fun if you ever get a chance to go watch it. Patrick Swayze plays a bouncer at a bar that's kind of rough, and he calls a buddy of his who also is used to going and being a bouncer at kind of rough places. He says, how's it going? And Patrick Swayze's answer is, it's no worse than we're used to, but it's pretty insane what we've gotten used to. And that kind of response is ridiculously common in the IT world, because you get this creeping commitment where, last month it took a second, and then 3 weeks ago it was 1.5 seconds, and you don't complain about the half a second, but 2 weeks ago it went up to 2 seconds, and now it's kind of slow, and then now it's 3 seconds, then it's 4 seconds, and suddenly it's awful, and it got there slowly. So you sort of become accustomed to it, and you get to the point where you're saying to your customers on the phone, hang on, our systems are running slow today. So we have some very specific case studies that we've done. And by the way, I can tell these stories pretty much all day. This particular one, we got a call out of the blue, and we got a lot of these calls out of blue from people who say, Jeff, somebody told me that you can help my performance problem. And I say, oh, who told you? Because I like to send a bottle of wine to say thank you. And for some reason, I rarely find out who recommended me, but I got the recommendations anyway. They say, we're getting 9-second performance on our website. Our marketing department is telling us we're losing customers like crazy, and that we will net $75,000 more per month profit for every 1 second improvement in performance. We took this down to 1/4 second, at which point our customer went dark and took us 6 months to get paid. But that's neither here nor there. My first question to them was, well, how about if you give me 5% of the extra money that I make you? And they said no. Very important, that perception of performance, particularly on a website. Another customer-facing issue was mostly internal. This particular group, based out of Atlanta, had 3,000 customer service reps that every evening would download their next 30 days of schedule. Why they would download 30 days of schedule every evening, I don't know. That's how they planned it. I guess they figured if their system was down for a month, they'd limp on through. But these downloads were taking up to 30 minutes or timing out. They said, can you help? Now, they were downloading an enormous amount of data, so there's some limitation about the network speed, but a lot of the issue is generating what needed to be downloaded. We dropped that time to under 2 minutes. Put the changes in, and the fun part about it was they had 3,000 customer service reps calling the helpline that night saying, hey, that 30-minute process seemed to finish in 2. Is this an expected result? They hadn't warned anybody because they didn't want to set any unreasonable expectations because they had no idea what the lines were going to do. But they said that was the happiest 3,000 telephone calls they ever got in one evening. So how are we going to take a look at this existing performance choose not to accept it, and move forward with it. My recommendation is to pick a tool, and this is why. None of these numbers are numbers that I've invented or even guessed at. These are coming from the Gartner Group, they're coming from the Forrester Group, they're coming from Microsoft white papers that were built internally. When you have an issue, the number of calls by the help desk to find the person to resolve it is 6. So one of your unquantified costs in poor performance is often what's going on right there at the help desk. Next, IT, and this is a nationwide average, spends 24% of its time on performance-related issues. To me, that is wild, and I did not realize this until I started asking a lot of CIOs and CTOs, and they said, yeah, that does sound about right. 30. This is neither Gartner Group nor Forrester Group. These are numbers that I got by talking to friends at load testing companies over beer. And what they say is that they hope to get 30% of your problems at load testing time. Considering the amount that people spend for load testing software, the amount of time they spend programming and setting up the load testing software, to me, this is just crazy, because that means that it's only picking up a small percentage, or a relatively small percentage, of your potential problems. Next number. Microsoft claims that most performance issues are caused by source code. I do question this number because I tend to fix an awful lot of problems by re-indexing data. It may be that before I get brought in, there's a lot of code that's fixed first, and I will always identify bad code and recommend changes, but I like that not infrastructure. Throwing hardware at a problem is generally masking the problem, not solving the problem. 73% of performance problems first reported by business users. This is another cost to you, because what ends up happening is you do performance and tuning by squeaky wheel, you end up with unhappy internal clients, and you end up with an antagonistic relationship with the business when it should be a symbiotic relationship. Final number, over 80% of mean time to resolution is spent finding the problem. And here's what I like about tools. If you can take that 24% of all the time in your environment and multiply that by the 80% of mean time to resolution finding the problem to identify the root cause quickly with a tool, that means you're getting back about 20% of your development time, testing time, the rest of it. This is a very significant number for a relatively small investment. So how do we find a problem? First, we identify it. I have had many customers that I acquired because they bought hardware, it didn't fix the problem, they brought me in to help explain to their upper management why they spent the money in the first place and get the problem solved in the second place. Note the sequence of priorities there. Next, once the problem is identified, we devise a solution, test the solution, and roll out the successful solution. That test and rollout is absolutely critical because this is often a repeat as needed type of thing. We want to continually test the performance, test the results, go back to the beginning. This is what tuning is. You're moving back and forth on that dial. In the case of the database, we're going to look at both the macro and the micro scale. So we're going to look at resources. Is the problem that we simply can't get the information off the disk fast enough? If we are tuned and we're still not getting the information off the disk fast enough, we need faster storage. But I will look at the macro level first, because if it looks like we are I/O bound, I will start by looking at the queries that are hitting the disk the hardest. And it may be that you're doing table scans where you should be using indexes, and we can fix that in a relatively quick amount of time. At the micro scale, we'll look at the individual queries. Once again, I like tools for this because it may be that the query that's really causing a problem is the one that's running at 1,000 times a second and taking a second and a half versus the one that's taking 3 or 4 seconds, and you really don't necessarily know what's causing the problem unless you can really look. So, things to look for in a monitoring tool. Make sure you're archiving the data over time. Make sure you can display the graphics over time. Really nice if the tool provides a baseline for you, so you can see if you're exceeding or matching or under exceeding your baseline. Make sure you can spot the performance outliers easily. The saying is the nail that's popping up is the one that gets the hammer. Well, it's really nice to be able to identify those nails and hit them with the hammer before people call and complain. Make sure the tool will alert you and let things know what's going on. Make sure that you can correlate the operating system information, also specifically any VMware or other VM type product information in, so that you know where the box is and where the slice is when you're looking at where the query loads are. Consider a tool that monitors things end to end, from user click to storage and back, so that you know if it's the user's box, his network, your application code, your database, your storage, your network, etc. Things not to do. If you are on the database performance side, do not let your operations team pick the tool. They will pick a tool that looks really pretty, looks great on the screens as people are walking by the operations center, but those are not usually the tools that are going to be best for a drill down for you. Those things tend to become very expensive shelfware. So, what is our approach? Once again, quantifying things. We first look at the operating system. Note that if you're a SQL Server shop, you do not want to run the profiler in your busy production environment. Very expensive. Fix, repeat as needed. At the OS level, the very specific things to look for are, at the I/O level, make sure the information is getting from your storage to your disk fast enough. On the Microsoft side, we look at disk queue lengths, because if we're not getting the information from the OS to memory and to the DBMS, doesn't matter how fast your storage is. I was at a shop very recently where we were finding that the disk queue lengths were in the 3 to 5 range, and the measured disk access time was 5 to 10 milliseconds. Well, if you are running off of flash storage, which they claim they were, they should be getting 0.3 to 0.5 milliseconds access time, not 5 to 10, and their disk queue length shouldn't be there. They had been reporting to their storage team that they thought things were slow but didn't know how to quantify it. But the storage team was saying, well, we don't look stressed on this side, and to be able to quantify that is very important. At the micro level, you can interview users if the tools aren't helping, but honestly, I tune without talking to the users first unless I think that politically I need to talk to them to hear what their issues are. You find lots of different things when you look at tools. Sometimes it's a single query that nobody realized was a problem. Sometimes the really slow things are in lock wait state. Well, you have to fix the blocking. It doesn't matter how fast the hardware is if the issue is locking. Sometimes a small set of tables has bad indexes. Well, let's go and take a look at things like that. Now, fixing the problems itself, hardware is usually masking a problem, not resolving it. I think in the last 3 years, there have been 3 times I recommended hardware changes, and I do this at least once a month, and more often 2 to 3 times a month. Sometimes it's server configuration. I was at a shop recently that had a 500 gig of memory, but their SQL Server was throttled down to 16 gig of memory. They said, well, the rest of it's just in case. I said, well, why don't you use more of the memory that you've got, and you're going to reduce I/O, you're going to reduce lots and lots of benefits there. I'm not going to get horribly technical on this call. Rewrite the bad queries where possible, add indexes. A lot of times that just makes you look an absolute genius. But the issue is you have to identify where the problem is before you solve it, because if you simply throw solutions at the problem, you're simply not going to get there. In the olden days, and I've been working with SQL Server and Sybase and other DBMSs for over 30 years, I used to write my own tools. Part of it is because other tools weren't available. Other reasons were that it simply didn't matter because the tools that were available weren't as good as what I was building myself. Today, I really like the tools that are out there. We've already talked about what I use these tools for and what I like to find. We've already talked about finding resources. One more case study. This one was a medical records provider. This one was kind of fun. We have a client that hosts third-party software for doctors and medical practices. And what we were finding when we got in there was that just opening up a patient file was taking these doctors between 10 seconds and 2 minutes, with the leaning toward closer to 2 minutes. And they were starting to get to the point where they were losing customers, which is obviously bad. So they brought us in for a tuning exercise. We knocked that down initially to 5 to 7 seconds. They said that was also not good enough. And we further identified that in order to improve it further, we were going to have to get them faster storage. We did. And they were coming in at 2 to 3 seconds. Now, the fun part about that was they went to the vendor show and asked, well, how fast should this be? And the vendor said 10 to 12 seconds. And when they said, well, we're down to 2 to 3, they were suddenly mobbed by every other hosting company there. They have since bought 3 or 4 of their competitors. High fidelity databases is another current catchphrase, whatever you want to call it. The meaning here is that data can become corrupted. Now, corrupt data is normally a software bug. Could also be a hardware bug. I've occasionally had bad hardware cause data corruptions. But in general, you want to regularly test the fidelity of your databases. SQL Server, that's a DBCC. And you want to make sure you do that before your data is, your backups are aged out, if in fact you age out your backups. We had one specific customer, and this was a customer that we acquired because of this issue, found that the backup solution they were using didn't work. They identified the corruption, couldn't get their data out. This company actually had furloughed 1,200 of their 1,400 employees because their data solution was not working. This is not something you want on your open enrollment day. The way we solved this, the vendor wasn't able to do the restore. We found a guy who had written his own go fix the Oracle software that was able to, over the course of 2 weeks, retrieve about 450 million rows of data and restore it. This has been a customer of ours now for several years, but they would not have been in business had we not been able to do that. Had they been running their high fidelity data checker, this would never have been an issue. Case study 2, how often does this happen? We were brought into a new client. They had about 125 SQL servers. They hadn't had a DBA for years. They had a network administrator who thought he was a DBA, did not understand what he was doing or how he was doing it, just that most of the servers seemed to be up and okay. As we started managing these servers, we found that of the 125, there were 3 servers with corrupt databases and partially irretrievable data. So sometimes you run 100 servers, you never have a problem. Sometimes you run them, and over the course of a few years, you develop some problems. But this does happen in all environments with all databases, no matter what the vendors tell you. Be aware and be cautious. So at this point, I'm done. I'm going to open this up to questions. A quick who's Soaring Eagles and what we do. We are a group of expert database administrators. We are all on shore. We are all expert. We are here for database managed services, data health checks, small projects, large projects, migrations to the cloud, off the cloud. We're currently working on a 200 Oracle Server migration to HANA. We are doing a number of SQL Server consolidation projects. We're doing full operational database support for dozens and dozens of very happy customers who we have for the long term. If you have any questions, please contact us or call us. At this point, I will look for questions on the presentation. All right, it looks like there are no questions, so I was either way too detailed or put everybody to sleep. I hope it was the former. If there's anything we can do for you, please reach back out. Have a wonderful day, and thank you for sharing this last hour with me.